Hello guys, welcome back to Abdu channel. In the last video, we have seen the features of Lambda expressions. Those are coming to Java language, Java programming language. And we talked about how we can pass a method behavior or the block of code to another method using object-oriented approach and also the functional programming approach using the Lambda expression. We have seen that in the with a detailed example. We also talked about how the data types of arguments or the return types are being matched with an interface. We also talked about the introduction of the functional interface. Okay. In today's video, we will take two examples and we will implement them using the object oriented approach and also the function oriented programming approach. Okay. Uh, let's see that. Okay. Let me take a class. Uh, the class name is thread test. Okay, this is actually having a main method, and this one I want to create a thread class here. Okay, new thread, not new thread. Yeah, new thread. If you see that thread class is having a zero argument constructor and also a runtime. Okay, let me take this. Here we have to pass the runtime. Runnable argument. Okay, runnable instance. So runnable is an interface, right, which is having only the run method. So in order to provide the implementation to that run method, we can create another class and implement that uh, from the runnable interface and pass that class instance here. That is the dynamic polymorphism approach. In the anonymous inner class approach, we can directly create an instance to the runnable instance, and we have to override the method, run method that is there. Okay, public void run method that is there in the runnable interface. Okay, so if you look at this, run method is called. Okay, now we have to start the thread, right? T dot thread dot start. Now if I run this program, what will happen we will see. Okay, I have to modify it for the program. Okay, let me run this. See, this is one way of providing an implementation class to your runnable interface by using the anonymous inner class. Okay, now we will convert this one to by implementing the lambda expression. Okay, again here in the earlier example we have seen that lion is an interface implementation class to your animal test, and we implemented the eat method here like this, right? So similarly we will provide the implementation here. Okay, and we don't have to specify the instance, right? And we also don't have to specify the public, because for lambda expressions we don't have to specify any access specifiers because they are not specific to any class. We don't have to specify the return type because it will be taken care or the automatically matched by the interface. Okay, this is the run method. The interface will be having the only one method, right? So that will be mapped with your lambda expression, so we don't have to specify the method name as well. So the run method is not accepting any arguments. After that we have to specify the arrow symbol as part of the lambda expression sequence, right? So we don't have anything now. Okay, this is We don't need this, right? In the thread constructor itself, we can directly pass the implementation of that run method. Where is this? Okay, see, this is just a one block of code, right, in that run method. So we can even remove this uh, braces because we don't have to loop them in uh, curly braces if we are having only one line of statement. So this is just a one line and it is an implementation to your runnable interface, and this one liner we are calling it as a method definition, and we are passing that to the thread class constructor. Now if you see that run method is still called. So this is an alternate version of your runnable interface approach, anonymous inner class approach, by using the lambda expression. Okay, this is exactly the signature which we have to follow when we are implementing the overriding the run method using the anonymous inner class, or when we are creating a class from the runnable interface. So how here, okay, here in the earlier example we have written some animal interface, and whatever the method or the lambda expression we have written, all those are compared here with against this animal interface. So the animal became a functional interface here. But here I have not written any interface, but how come the parameters or the return types are being matched here? Because it accepts the runnable argument, runnable instance, right? So whatever the method definition you provide here, that will be mapped to the method which is run method that is available in the runnable instance. Okay, runnable interface. Okay, let me open it. Runnable. If you see this, the runnable interface is having a method run, and it is also marked with that functional interface. Okay, when an object implementing interface runnable is used to create a thread starting, the thread causes objects run method to be called in the separately. Okay, this is the feature of the run method. This is the specification of the run method. But whatever the argument you are passing to your thread class constructor, that will be mapped with your runnable interface and with your run method. Okay, because thread class constructor is accepting a runnable interface here, so that the runnable interface will be coming into picture to pick up this lambda expression, or the lambda expression will be matched with the method that is available in the runnable interface. That is how the type inference is being taken place here. Okay, type inference is something checking the data types of the arguments, or the checking the data type of the return value by using the functional interfaces for your lambda expression is called a type inference. Okay, so any interface which is being mapped with a lambda expression is called as functional interface. Okay, so that is one example. Let us go to another example. Okay, here what I will be creating is my window test. Okay, this is one of the class. Here in this class, what I will do is I will create a Java Spring framework related frame window. Okay, on that window, I'll give a button. On click of that button, I have to handle the implementation method of that click event. Okay, so we will see that with an example how we can do that using object oriented programming approach and also the functional programming approach using lambda expression. Okay, now let me write that program. Okay, here we have to mention JFrame, right? Okay, I'll extend my class from JFrame. Okay, I'll give it I'll have to have only one component, that is button. Okay, in my window test, okay, in my class constructor, I'll initialize that button with click here text. Okay, now I'll set some boundaries as well. Set bounds, some location where you want to show that, or the size of the button. Okay, now when I click on it, when I click on and see, this is the action listener method, button dot add action listener. Okay, adds an action listener to the button. So the moment you click on it, you have to pass the action listener implementation class here. Okay, action listener is an implementation, so we have to give it here like this. We have to provide the implementation to action listener here. The moment you provide the implementation, you have to override the method that is available in the action listener. Okay, so what is that method that is available in the action listener? We can see that action performed is a method. That is the only one method, right? So public void action performed, and it takes an argument action event e. I'm just handling that button event. Okay, see, this is one of the way to implement the action listener interface, or to provide the definition to the method that is available in the action listener interface. Okay, by using the anonymous inner class approach. Now I'll add the button to frame. I'll also set the size of frame window. I'll set the layout to null for now, and I'll set visible to true. Okay, so this is the minimum program which we write. What happened here? Visible. Okay, minimum program which we write to show a JFrame window in Swing. Okay, here it is not having any main method. I'm just giving a constructor because all my logic present in a constructor, right? So now if you see that the window is open, and when I click on a button here, you can see that logger is getting printed. Okay, so this is how we handled the event of on button click by using the anonymous inner class, by providing the definition of action performed, which is there in the action listener interface. Okay, now we will convert this expression directly into the Lambda expression. Okay, button dot add action listener. Okay, here what is that we are doing? We are passing action performed. We are providing the definition to action performed, and that is the only one method, and it is accepting an argument e, action event, right? So we will start with this like this. Okay, action event, we have to provide the arrow and we have to provide the definition. Okay, that's all. Lambda. Okay, now if I run this program, see that button event handled from Lambda. See, we have seen that how we can provide the implementation using an anonymous inner class, and we converted that into a lambda expression. We here, while we are writing the lambda expression, we don't have to provide the method name, because here add action listener accepts action listener interface. So the moment you provide the arguments, whatever the action listener is present, that will come into picture, and it will try to add, it will try to map your lambda expression signature with your interface method, that is the action performed. Okay, because that is the only one abstract method that is there here, right? uh, in the action listener we have seen that. Okay, so that's all about converting these uh, anonymous inner classes approach into the lambda expressions. So these are the couple of examples which we can see how we can write the more precise code using the lambda expressions in all these places, right? In the earlier example we have written the interface. In these two examples we have not written the interface, right? So whatever the interface that is coming up or shipped with the Java programming environment, that is being compared with your lambda expression. Okay, so we will see a couple of examples. What are the different interfaces that are available and how they are coming into picture when you write some lambda expression. Okay, that we will see it in the next video. That's all for today. Thank you for watching.